children, how are you? I hope you all are safe and fine and taking prevention for this COVID-19. I am doing the same thing what you are doing. So come to the next part of the tangents and seconds to a circle. The next part is a theorem for you all. So see what is the theorem? The theorem, I said you when you are going to write the theorem, you are maintaining your procedures. That is the statement. What is the statement? The lengths of the tangents drawn from an external point to a circle are equal. The length of the tangents drawn from an external point. So there is an external point. From that external point, we are going to draw two tangents to the circle. And we have to prove that those are equal. Those two tangents we draw, that two will be equal. So now you see, given is a circle. I took a circle of center O. And P is passing outside the circle PA. P is the point which is outside the circle, and PA and PB are two tangents, P to A and P to B. Clearly they are touching the circle at one point only. So PA and PB are the two tangents drawn to the circle. So now from the external point P, from the point P we are drawing PA and PB. See now, I joined the radius. This is the radius OA and this is the radius OB. And I joined the O to P also. Okay. So now my figure is complete. Come to the RTP. That means right to proof. What you have to prove. Now PA is equal to PB. You have to prove P to A is equal to P to P. That one you have to prove. You have to prove this tangent is equal to this tangent. Understood? Now come to the proof. Now we are going to do the proof. See how the proof will be done. I said you join OA, OB and OP. O to A, O to B and O to P. These three you have to join. You join. Then this is the first theorem. The radius at the point of contact to the tangent is perpendicular. That means this is 90 degree and this is also the radius at the point of contact. It will give you to the tangent, it will give you 90 degree. That is right angle. So OAP angle is equal to OBP angle. OBP angle. We wrote it here. OAP angle equal to OBP angle, that is equal to 90 degree. It is the first theorem. Now I proved here. See now. Now in two right angle triangles. What is that? OAP and OBP. In triangle OAP and OBP, what is happening? See now, we have to show the concurrency proof. What is the concurrency here? These are two right angle triangles, OAP and OBP. These are two right angle triangles because 90 degree at here. So there are two right angle triangles. So we have to adopt the RHS concurrency. That means right angle, hypotenuse and side. We have to make same for two triangles. So now, see now, O to A is the radius, O to B is the radius. So OA equal to OB. Finished. Next what to do? Next you have to show a right angle. OAP angle is equal to OBP angle. I wrote it here. OAP equal to OBP equal to 90 degree. One right angle came. Then one side came. OA equal to OB. Then what is that? Hypotenuse. See now, this is the perpendicular, this is the base. So compulsory this is the hypotenuse and this is the perpendicular, this is the base, this is the what? Perpendicular and this is called as the hypotenuse. OP is the common side. See OP equal to OP for the both triangles. This side is common for both. So it is a common side. So now side, angle, side. So right angle, hypotenuse and side. By RHS concurrency. See now by RHS concurrency we are going to say that triangle OAP and OBP, both the triangles are congruent. So what type of congruency? RHS congruency. That means right angle, hypotenuse and side is same here in triangle OAP and in triangle OBP. So now AP is equal to BP. What is pending now? So this is equal to this. This side is equal to this side. This is the common side both for both of the triangle. Then what is remaining? AP is equal to BP. I wrote here And AP, and what is AP? AP is the tangent. And what is BP? BP is also a tangent. So now we prove that two tangents are equal also. Now it is proved. I hope you understood. So what is the statement? The lengths of the tangents drawn from an external point. From an external point, if you draw two tangents to a circle, then they are equal. This will be equal to this. That one is our proof. We did it nicely. Very easy proof. But this proof is very, very important. It will come in the exam. If circle theorems will come, then this is the theorem you have to remember, you have to practice nicely. Now come to the next part. The next part is a very interesting part. It is a construction. Construction means you have to prepare with your geometry box with you and try to do the construction with the explanation. So now what is that? Construction of tangent to a circle. Construction of tangent to a circle from an external point. So there is an external point, there is a circle, and from that external point you have to draw two tangents to the circle. I am explaining here. See now, suppose that here it is a circle, here it is the external point. So you are going to draw two tangents to the circle from this external point. From this external point you are going to draw two tangents. So let it be P. So this is the point. Construction of tangent to a circle from an external point. From an external point, we are going to draw two tangents to the circle. Here, I will do the construction now with these steps involved. Step is step 1, step 2, step 3, step 4. There are steps are involved in it. So, with the step, I am doing the construction. Please try to understand it nicely. See now, draw a given circle of center O. What is the question? What is the radius? To that radius, you have to draw a given circle. Suppose I am taking the radius here 5 cm. 5 cm circle I have to do. First I go for a 5 cm circle. Understood now? This is, let it be the center O. And let me join the radius. Let it be X. Now what is this one? 5 cm. Understood now? Step 1 is draw a given circle of center O. Okay. And a point P outside the circle. You take a point P outside the circle. I am taking that point P. It will be given to you on how much distance the P point is from the center. You please mark it. It is from the center or from this X point. Read the question carefully. From X point, then you take that much distance. If it is from the center, then you take from O to P that much length. So let it be O, it is from the center, let it be 10 cm. So another 5 cm I have to draw. So 5 cm, 5 cm. Now it is how much total distance is? 10 cm. Okay. So it is from the center now. It is from the center to the outside point P. The distance is 10 cm now to give it to us. So we already draw the first step now. Come to the second step. What is the second step? Join OP. O to P. You have to join it. So already I joined it, O to P, and draw a perpendicular bisector of it. Perpendicular bisector means line segment division. Take more than, you know what will be the middle. The middle will be here. But you take more than middle arc from in the compass and give a arc here and here. Okay. Now from this side, got it, and it will give you what? It will give you the perpendicular bisector now. Okay, so it is not coming here, I am putting it here. It is now the perpendicular bisector of OP line. You understood how to do the perpendicular bisector? You are taking the line and you imagine the middle. The middle will be here and somewhere. More than middle, more than half. You take in your compass the arc, put a arc here and here. Then same measurement, put it here and cut it and join it. Let it be M point. He is saying you, let it be M point. Which point? Let it be M point. Let M be the midpoint of OP. So OP midpoint is M now. So OM is equal to MP. O to M is equal to M to P. Because it is the perpendicular bisector which is giving you the midpoint of the OP. Understood now? Come to the step number 3. Very slowly I am saying. Try to understand it with me. Again I will say you. Taking M as center. And this one as radius. M to P or M to O, whatever you take, that is both are same. M to P or M to O, you draw another circle here. You draw, he is saying take M as center and MO or MP as radius. The center will be here. Draw another circle. Okay, draw another circle, and please try to remember this circle will definitely pass through P point. Clear? This circle is definitely pass through the P point and O point also. This circle will definitely pass through the P point and the O point. That one you have to remember. This will pass through the P point and O point, and again you have to go for the joinings. Clear? Now you see, now you join. So now what is our circle? This is our circle. By the radius, this one, by center M, you draw another circle. Now you see this circle, original one, was cut in 2 points. It was cut in 2 points by the circle you created now. So let it be, this point be A point, let this point be B point. Clear? So after cutting or intersecting this circle in 2 points A and B, you please join O to P, O to P, and also O to this one B. Clear? So now AP and BP are the two tangents. Now AP and BP are the two tangents. Understood now? Just I am taking the point nicely and the line nicely. So now this is the point we have to join. This is the point we have to join now. Clear now? So now AP and BP is called as the required tangent to the circle. Again I am saying to you, the thing is that it is the external point, the desired, draw a given circle of desired center. Then I took the radius 5 cm and draw a circle and put it the name as O. The center is O, and where it is touching there is X. Then what I did, I took the outside point P. P is the outside point. So O to P distance it will be given in the question. You see from the center how much distance the P point is. Take that much and join OP and take the perpendicular bisector of this OP line. After taking the perpendicular bisector, next go for the measurement of the radius. This is the radius. As M as center, draw another circle. M as center, draw another circle. Clear now? So draw another circle as M as center, which will cross the original circle, in 2 points. So these 2 points to be joined to P. So PA and PB is called as the required triangle. I hope you understood it and the steps involved in it. Okay, so this is the construction from the tangent to a circle from the external point. Students, here you have to be very, very careful. See the outside point distance. It is from the center or from here, the radius end. From here to here it is given in the question, or it is from the center. If you do that one, it is definitely give you a clear construction. So I hope you understood it. Now come to the next part. The next part is, this is a very, very important construction. Please try to understand very carefully with me now. Construction of tangent to a circle from an external point, already we did. Now, construction of the triangle tangent to a circle from an external point, already we did. So, take the outside point, join it, take the perpendicular bisector, and get the midpoint, and through the midpoint and the desired radius, you are drawing another circle which is cutting the original circle in 2 points, and you are joining as a tangent. But after that, what is it? It is here, see, which are inclined at an angle 60 degree, which is inclined at an angle 60 degree. That means here I did through a question to explain you nicely. The question is, draw a pair of tangents to a circle of radius 5 cm which are inclined to each other at an angle 60 degree. So both are inclined to an angle 60 degree. To do this, first we have to go for a rough figure. So what is the rough figure? See, very slowly I am saying. This is called as the rough figure. I draw a circle of radius 5 cm. I draw it. So radius circle is 5 cm. Okay. Now outside the circle there is a point P. There is a point P outside the circle. But from the center to the outside point, the distance you don't know. You only know the radius of the circle, but this much distance you don't know. Let it be x. So x to P you don't know. So you cannot take the point outside. So the construction you cannot able to do. For that reason, we have to know the XP distance or the whole distance from O to P distance or XP distance. If you know, then we can able to draw the construction. So I did a rough figure for you. I draw a circle. This is my radius. This is my radius. Radius is touching the tangent at 90 degree. Here it is also touching the triangle at 90 degree. And I joined OP and my inclination angle is 60 degree. So if it is 60 degree, this line OP is right now dividing this 60 degree into 30 and 30. So here two triangles are created. One is OAP, this triangle, and another triangle is OBP. Both the triangles are congruent. Right now I proved the theorem for it. Okay. So now you see, here is a right angle triangle. In this right angle triangle, see now, this is perpendicular. So this is the base, this is the base, this is the base, and this is the perpendicular. This is called as the base, this is the perpendicular, and this is the hypotenuse. Clear? Understood? Because on AP, the 90 degree is there, and AP, the 30 degree is there. So this is called as the base. A to P is called as the base of the triangle, and A to O, it is called as the perpendicular. So it is a right angle triangle where base is this one. I am writing here base, and this is called as your perpendicular P, and this whole distance is called as your H, means hypotenuse. Understood now? I hope you understood. So how to do this? See now, some rough calculations are there. After that we will go for the fair construction. Try to understand how I am getting the length OP, O to P. This length I need now. How to do? See now. Let us consider an circle of radius 5 cm, okay, and center O. Give the name as O. Clear? Let P be the outside point. P is the outside point from where PA and PB, two tangents, PA and PB, two tangents are drawn with an inclined angle of 60 degree, giving you inclined angle of 60 degree. So join OP now. This is 30, this is 30. So here it is written join OP. As we know, OP is the bisector of angle APB. APB. This big angle, bisector is OP. So this small angle is 30, this angle is 30. That means APO angle is 30 degree and OPB angle is 30 degree. I wrote here OPA and OPB angle is equal to 30 degree. Now you see, now in triangle OPA, please come to one triangle OPA. This is the base, this is the right angle triangle. See now, this is the right angle triangle. Like this it is there in your figure, like this it is there. Clear now? So now this is the base, because it is 90 degree, it is 30 degree. So this is base, this is perpendicular, and this is called the largest side hypotenuse. Hypotenuse. Clear? So now you see, this is a right angle triangle. In trigonometry chapter, we are having some trigonometric ratios. Now you put that, I will explain you later the trigonometric ratios. So trigonometric ratio sine 30 in a triangle, sine 30 is called as perpendicular by hypotenuse. Perpendicular by hypotenuse. That much you understand now. Perpendicular by hypotenuse. So I put here perpendicular is OA, by hypotenuse is OP. Okay. So it is here A O P. So perpendicular is OA and hypotenuse is OP. I wrote here OP by OA. OP by OA by OP. Perpendicular by hypotenuse. So now when you will go through trigonometry, you will know sine 30 has some value. The value is half. Just right now you just remember this. Sine 30 is 1 by 2. 1 by 2 equal to OA. OA is given. OA is 5 cm. 5 by OP. Then cross multiply. OP into 1. OP. 5 into 10. So look at it. What came? O to P came. O to P is 10 cm now. Now you know the distance from the center to the outside point, that is 10 cm. Now you can do the construction nicely. For that reason, this much rough figure and this calculations you have to do. What I did in a right angle triangle. Here it is 90, here it is 30. So definitely what I did, I took this triangle and put sine 30. What is that? Sine 30. Sine 30 is a trigonometric ratio. So sine 30 is sine theta, sine 30, sine 40 or sine theta is equal to perpendicular by hypotenuse. That much you have to understand. Perpendicular by hypotenuse. Perpendicular is OA by hypotenuse is OP. OA by OP. So what is sine 30 value? Sine 30 value is 1 by 2. Remember it. 1 by 2 is equal to OA by OP. OA is 5 centimeter. OA is 5 given. So 5 by OP. Then cross multiply OP into 1 OP. 2 5s are 10 centimeter. When the question will come in the exam like this, incline and angle 60 degree, first of all you have to go through a rough figure. Then you calculate the distance from O to P by putting sine. And after that, getting the distance, go to the fair construction. Fair construction is very easy for you. Why it is easy for you? Because it is the first construction you did now, just now. So take a circle of radius 5 centimeter and join the radius, that is O to X. Then what is the distance from the center to the outside point? You got it now, 10 centimeter. So from center to the outside point, the distance is 10. You take 10 centimeter and here you draw a perpendicular bisector for OP. Perpendicular bisector means the line bisector. Line bisector means you have to divide the line and to get the midpoint M. To get the midpoint M. So after getting the, you know how to do perpendicular bisector, take more than half, encompass the arc, and from one point go, and from other point you cut, and you will get the perpendicular bisector, which is bisecting the OP line at M point. That M point is called as the midpoint. So OM is equal to MP. Now what to do? I said you, taking M as center, MP as radius, you have to draw another circle which will pass through O and P. If it is not passing through O and P, it is wrong. Your perpendicular bisector is wrong. So for that reason, again choose the perpendicular bisector and do it. Definitely that one will pass the O and P. O, P. Both it will pass. So after that, which point it is cutting? The original circle. That is, give them A and B point. Join A to P and B to P. And the required tangent is ready now for you. I hope you understood this. And before doing this incline and angle 60 degree constructions, you have to go for a rough figure, then do some steps for the rough figure, how to get the distance between O to P. O to center to outside point, the distance you must get by putting this in right angle triangle sine theta. Sine theta means sine 30. Sine 30, you will get this measurement. This is the hypotenuse. This is the measurement you got. After the measurement you got, you can go from O to P 10 centimeter, because but it is not giving your O to P how many centimeters, so you cannot do this distance. This distance you have to get by putting these procedures. After that, you proceed to go for the fair construction, taking a circle of 5 centimeter. Then from O to P 10 centimeter. Then you have to bisect this O to P 10 centimeter. So this part is 5 centimeter. This part is 5 centimeter. Taking M as center and draw a circle through M, which is cutting the original circle in A and B points. Join AP and PB, by which the two required tangents will come to you nicely. I hope you understood this part. This is a very important construction. Please practice it nicely. Now come to the next part. What is the next part? Construction of tangent to a circle where the center is not known. You don't know the center. That means center is not given to you. That means radius is not given to you. The outside point also, the P is not given to you. Then we have to draw two tangents to the circle. We have to draw two tangents to the circle. See, now I am taking a question for it for better explanation. What is the question? Draw the circle with the help of a bangle. Draw a circle with the help of a bangle and take a point P outside the circle. Point P outside the circle, you have to take it on your desired length of your own wish. You have to take the outside point. Construct a pair of tangents from this point. So now, important point is that I draw a circle with a bangle, but I don't know the radius. So, but I don't know the outside point where to take, because radius should be joined to the outside point. So it is not there. See, now steps are written here. Draw a circle with the help of a bangle, big bangle. Big bangle to take a circle. Draw two non-parallel chord. What is the meaning of chord? The line joining the two ends of the coil. It should be non-parallel. That means here if you are taking one, you take one from here. Clear now? Now you start to bisect it. Line bisector, you know, more than half arc. Then put a point here, put a point, then from here, and then from here, and join it. Join in dotted lines. It will be good for you. Join in dotted lines. Clear? Now I got my bisector of this chord. Now what I am doing, see, I am bisecting this chord also, this chord. So now take a perpendicular bisectors, and also from this point go through this arc, from this point go through this and join it also, and join it also. See now, extend them. Where they are meeting, that is the center of the circle. That is the center of the circle. Now you got the center. Clear? Now you join the line. This is called as the radius. Understood? Now take the outside point and intersect it and bisect it. Where they join, the name it as center O. This is our O point now. So what we did, two non-parallel chords we bisect it. Here it is one chord and here it is one chord. So we bisect two non-parallel chords to get the center. Center O is coming now. Now after getting the center, you have to take a point P outside the circle. You have to take a point P which will remain outside the circle on a desired length. How much you wish, that much you take, no problem. So within 15 centimeter you take B2 because your scale is 15 centimeter. So take 10 centimeter is a good distance. So take a point P and join this hole. Join this hole. I am joining now. Join this OP, and what is your OP? Write the distance here. It is 10 centimeter you have already taken. Clear? Now OP is 10 centimeter. After doing that, it is the same construction you did in the first one. That is, you have to divide the OP, line bisector of OP. You have to go for the line bisector of OP. Take more than half, then do 2 here and 2 arcs from here also, and join them to get the midpoint of OP. To join them to get the midpoint of OP. That is the midpoint M. So MP or MO as radius and M as center. Don't forget, M as center. And MP and MO as radius. Draw another circle. Draw another circle which will definitely pass through the P point and O point. Clear? You can draw the dotted circles also. It will be good for you. Clear now? Now you see where this circle is intersecting. That is A point. Here it is called as B point, and you can draw the tangents to the circle, that is P point. Sorry, this is the tangent to the circle P point, and this is the another tangent from B point. Join these two tangents. Clear? This is one tangent, this is another tangent. Little bit okay now. So now AP, give the arrow mark nicely. This A point, this B point. So BP and AP are the tangents from the circle. Which center you didn't know. That one I wrote, join OP and bisect it, join O to P and bisect it, and name it as M, for the midpoint. After that, MO or MP as a radius. MO or MP, both are same. So through M, one important thing you have to know, through M as center and MO as radius, draw another circle nicely. Draw another circle where it is cutting the original circle, put point A and B and join AP and join BP. This is the construction we got where we don't know the center of the circle. By the help of a bangle, we are taking the outside point and also on our own wish and also drawing two tangents to the circle. I hope you understood. Here the trick is that draw a bangle, draw a circle in the bangle and get two non-parallel chords. Two non-parallel. This is one and this is one. So both are non-parallel and they bisect them. Where they are meeting, that is your center. Center point after, it is the construction same as the construction you did in the first construction. I hope you understood it and practice it nicely 2-3 times because these constructions in the circle are very, very important. Some students are doing it by hand to practice it in hand, but 2-3 times you please try to do it in compass and scale also, ruler and compass also. It will be good for you. Now come to the most important part of this circle. Many sums will come from this part, that is called as the finding area. I am again saying area of the segment, of a segment. You are going to find the area of a segment, which is sometimes called as sector. Segments means sector, a part. Now you see a big circle was drawn by me. What is this circle? Let the center be O and this point be A, this point be B. Now you see this point, let it be X, another point. Okay. Now you see I draw a circle and I draw two radius of that. See now, One is called O to A, another is called O to B. So OA is equal to OB. When this circle is drawn by two radius, see, a person is coming out from the circle. This section is coming out of the circle. Okay. So this is called as a part. This is called as a part, otherwise called as a sector. I just did the sector figure here. Again I am doing. See now, this part I took out of the circle with some radius. So here it is a radius, here it is a radius, and this is called as the arc. What is this? Length of the arc. Length of the arc, or it is called as L. I will say it. So this is L. R, and this 2R is creating a central angle. In the center, some angle is created. That is called as central angle. I wrote it here. See now, this A to B is a line which is joining the circle in two distinct points. So AB line is called as the chord. I wrote it. This chord, take the chord into account. Forget about this one. This chord is right now dividing the circle into two parts. One is this one, and another is a small one. The small one is called as the minor segment. This is called as minor segment. And in this minor segment, there is an arc here. That is called as minor arc, or L I said. Clear now? Now come to the point AB when it is dividing, there is a big part here. Dotted, it is shown by dotted lines, blue dotted lines. So this part is called as the major segment. So this part is called as minor segment, and the arc is called as minor arc. This part is called as major segment, and the arc is called as, from here to here, the arc is called as major arc. I hope you understood. So this chord is dividing the circle into two parts, a big one and a small one. So this is called as segments. This is called as segment. Clear? Another segment you right now observe. See now, when a radius is joined and this part is coming out of the circle, is looking like this. This is called as a sector. What is this called as? It is called as a sector. This is a sector. So when you will when somebody will ask you what is a sector, you can say the space created by the two radius of a circle and the arc of the circle is called as the sector. Understood now? Clearly, I hope you understood. There are some symbols are involved for it. I already wrote the symbols. See now, the symbols are, arc can be denoted by L. This is the arc. We can write it by L. And central angle. This is the central angle. The angle created by the two radius is called as the central angle. This can be symbolized by theta, and the radius can be symbolized by R. You know it. So theta, L, R. Theta, L and R is giving you a what? A sector of a circle. Sector of a circle means a segment of the circle described by the radius with a central angle, with radius, and also the length of the arc. So the figure is here. I did it for you like this. Now you see, some of the important formula is related with this sector area. If you know this formula, then you can go through the sums nicely. Otherwise, you cannot do the sums. So what are the important formula? The formula is the perimeter of a sector. What is the perimeter? The surrounding. The surrounding, see now, here it is there. One man is here and coming down to here, and again going down to this part, and again going to this part. So what he covered? He covered the surrounding of the sector. He covered the surrounding of a sector. So how much he covered? That is called as the perimeter of a sector. That means R plus L plus R. That is written here. R plus L. That is 2R plus L units. Because perimeter always come in units. Now you see the length of the arc. What is the length of the arc? What is the arc? If anybody will ask you what should be this arc only, this arc has a formula, direct formula for you. You have to practice it nicely. That is L. Arc means L. L is equal to pi by 360 into 2 pi r. The formula is pi by 360 into 2 pi r. Please remember it nicely. The formula is pi by 360 into 2 pi r. 2 pi r. Here is the difference units. Why I will tell you. Next, the area of the sector. What is the area? The space inside this. That is called as the area of the sector. What is the area of the sector? the area of the sector is half into L into R. Look, when this formula is not in your book, so but I gave it to you to practice. Why? Because when the area is asked and what is given to you, the length of the arc is given to you, the radius is given to you, length of the arc and the radius is given to you, then the formula will be area of the sector will be half into L into R, half LR, that is called as half into L into R. But when the central angle theta is given and the radius is given, see the difference, the theta is given, R is given, here L is given, R is given. So when the theta is given and R is given, the area of the sector will be a direct formula, that is theta by 360 into pi into R square, theta by 360 into pi into R square. I hope you understood it. That must square units, because areas always come in square units. So these are the involved formula for this sector. Now you see what I said. First one is the perimeter of a sector, that is 2R plus L. And the second one I said the length of the arc length, that is equal to pi by 360 into 2 pi R units. Then area of the sector always come in square units. When LR and R is given, that is half into L into R. And when it is area of the sector, when theta and R is given, theta means central angle, and the radius is given, then the area is equal to theta by 360 into pi R square units. I hope you understood all the theory behind this sector. What is this otherwise called as sector area or segment? Segment means when a chord is touching in two distinct points, it is dividing the circle into two parts. The one is called minor segment, very small one, and another one is called as a major segment. This one is called as a major arc and this one is called as a minor arc. I hope you understood it. And another point I want to say you, this biggest chord which is passing through the center, see now, this is the chord, but if this chord will pass here, this is the biggest chord. So which is passing through the center, also touching in 2 points, let it be M and N. So Mn is called as the diameter. So biggest chord is called as diameter, which is dividing the circle into two equal halves. Each half is called as a semicircle. Understood now? In semicircle. So this theta will be given to you in the question. This R will be given to you in the question. Sometimes L will be given in the question, and the question will ask you to find out the area or the length of the arc if it is not given to you. So please try to practice these formulas nicely, by which you can able to do the sums very nicely. Go to the next part. Now come to solve a sum. Sum for the finding the area of the sector or segment. I have already taken a question for you. Look at the question. Find the area of the minor segment. I wrote it in black, by which what area you have to find out. You can focus to that. Find the area of the minor segment. If the radius of the circle is 10 cm, radius of the circle is given to you, and angle subtended by the chord at the center 90 degrees. So central angle is given to you 90 degree and the radius is given to you 10 cm. We have to find out the area of the minor segment. Okay, let's start. Solution. In the sector, I did a sector figure here. See, where my central angle is 90 degree, my radius is 10 cm. This is the chord subtending the angle 90 degree here, and what is the minor segment? This is my minor segment. This is my minor segment. Okay. So what is minor segment? How can you calculate the area? You from the sector area, if you will subtract the triangle area from the sector area, full sector area, if you will subtract the triangle area, then the area of the minor segment will come. That is the formula involved in it. Okay, let's go for it. Area of the minor segment. What is area of the minor segment? Area of the sector OAYB. You have to name like this. Minus, that means the area of the whole sector. Okay, minus area of triangle OAB. Area of the triangle OAB. This triangle area you have to minus it from the whole sector area. Then the minor segment AYB area will come. So what is the area of the sector? As you know, theta is given, R is given. The formula should be adopted. Theta by 360 into pi into R square. I wrote here theta by 360. Theta is 90 here. 90 by 360 into pi. Pi is 22 by 7 into R square. 10 into 10. Minus, what is the area of the triangle? Half base into height. half base into height. Now I cancel 94 ja, then 2 2 ja, 2 11 ja, then 2 5 ja. So 11 5 ja 55, 10 ja 550 by 7 minus 2 5 ja, that is 10 5 ja 50 by 1. After taking LCM, 7 550 minus, it will be 350. So it is 200 by 7. So what is coming? 28. If you divide it, it is coming 28.57 square centimeter. Very easy sums. So if you are getting formulas right, that means area of the sector, area of the triangle, area of the minus segment. Area of the minus segment means whole sector area minus the triangle area. That one you have to understand and practice. So you can go for it nicely. Okay, I hope you understood it. Now this is called as the concluding part of the tangents and seconds to a circle. This chapter, this is called as the concluding part. Now I hope you understood it nicely. Practice the constructions, theorems and the related sums in your rough notes or in your practice notes nicely. Get through the formulas nicely, by which you can able to do all types of sums asked to you. I hope you understood it. Take care. Thank you very much.